Hello friends, today we'll see the problems on equilibrium of parallel forces in space. Then which are the basic steps you have to follow while solving these problems. Very first step is what? Equilibrium means always we'll have to draw the free body diagram. First step will be free body diagram. And once we draw the free body diagram, then we'll use the conditions of equilibrium. Then how we'll be using these conditions of equilibrium? That twice summation m is equal to 0, and then once summation f is equal to 0, we'll get the answer. Means 2 times we have to use summation m is equal to 0, and in the space forces it will be about some edge or some axis. It is equal to 0, and then later on summation f is equal to 0. If we remember this, then we can solve easily the problems on equilibrium of concurrent forces. Now we'll see the very first example on this, and this example is what? The uniform concrete slab has a weight of 5,500 Newton. Determine the tension in each of the 3 parallel supporting cables when the slab is held in the horizontal plane as shown in figure. And especially in these parallel forces, when more than one answer is asked, it is the problem of equilibrium of parallel forces. The first step while solving the problem of equilibrium of parallel forces is what? So we have to draw its free body diagram. Then how the free body diagram will be? So vertical is z axis. So in this direction y axis, and in this direction x axis. Then there is a slab. It is 0.6. So this is the slab. Then so it is at the center. Again it is at 0.3. It is 0.6 meter, 0.3 meter, 0.3 meter. And whenever we are drawing the free body diagram, what we have to do? See, this is the slab, and it is supported by 3 cables. One is at A. So this is A, and it is TA. We'll have to cut this cable. Then other is at B. So this B is also B, TB, and third is at C. Third is at C, TC. So these are the 3 forces. At the same time, we have to show its weight also, where the weight will be exactly at its center. That means it is something like this, vertically downward force, and it is 5,500 Newton. So it is y-axis, it is x-axis, and it is z-axis. So it is what? The free body diagram. The free body diagram is like this. Just I'll repeat. It is the plate, rectangular plate, and it is supported by 3 cables like this. TA, TB, TC, and this is going to be a weight vertically downward. So its free body diagram means 4 forces are acting on this plate. Then what I have told, first is the free body diagram, and then second is what? We have to use summation or moment condition, summation m is equal to 0. Now on y-axis TA and TC is acting. So it is better to use this condition first. Summation m about y-axis, it is equal to 0. It is equal to 0. This is the equilibrium condition of moment. Then moment of TA and TC is 0. The moment of TB, so actually it is 0.6. This is 0.6 meter. TB about y-axis, TB into 0.6. And the moment of 5500 about y-axis, it is anti-clockwise, minus 5500 into 0.3, half of it, it is equal to 0. Means TB is 2750 Newton. Means out of 3 answers, we got 1 answer. Then once again, using the moment condition, summation m about x-axis, it is equal to 0. Then what is the moment about x-axis? The moment of 5500 is clockwise. 5500 into 0.6, it is clockwise, minus TB 2750 into 0.9, minus TC into 1 TC into this distance 0.6 about x-axis, it is equal to 0. And if we make this calculation, we will get TC is equal to 1375 Newton. So like this, what I did, I used 2 moment conditions of equilibrium. Summation m is equal to 0. Twice summation m is equal to 0. Now summation f is equal to 0, this condition we have to use. And all these forces are along the y-axis or parallel to y-axis, then that condition must be summation fz is equal to 0. Then what we'll get? TA plus TB 2750 upward plus TC 1375 minus weight 5500, it is equal to 0. And if you again make these calculations, these are very simple. TA is equal to 1375 Newton. This is again one more very famous and simple example of equilibrium of parallel forces. And now we'll see the second example on this equilibrium of parallel forces. What is it? A rectangular plate of negligible weight is held horizontally by 4 wires of equal length at A, B, C, D, as shown in figure. If the minimum force in any of the wires is 2.2 kilonewton, find the forces in the remaining wires. Actually, in this problem, what is there? So, there are going to be 4 cables or 4 wires. Out of that, 1 is given, means 3 unknowns are there. Those we have to calculate. Again, as I told, very first step over here is what? Drawing the free body diagram. Drawing the free body diagram. And this free body diagram, how it will be? So it's a rectangular plate of 400 by it's 500 mm and this is 400 mm. If we cut all these cables, we'll get at A, this is going to be a tension at A, this is TA, it is TD, it is D, it is TD, it's a B, it is TB, and it is C, it is TC. And actually, the weight is acting somewhere over here. and this weight is vertically downward, and it is 16 kilonewton. 16 kilonewton. It is 200 mm and it is 150 mm. So this distance of this weight. Actually the weight is acting at this point. So this is what the free body diagram. So here 5 forces are there, TA, TB, TC, TD, and the weight is acting vertically downward. So out of this, one is known, 2.2 kilonewton minimum. Then if this weight is acting at this place, the minimum tension will be in the wire which is most away from it. And that most away corner over here, it is TC. Hence, T minimum is going to be TC. It is going to be 2.2 kilonewton. Means one answer we got. Means taking this decision is also very important in this problem. Then after that, as I told, we have drawn the free body diagram. Now we have to use 2 times summation m is equal to 0. Then just check TC is known. Means if we use arc, so it is what? T, it is B, T, A, B, C, D. So, or even though we can consider these sides x-axis, this size x-axis, this side's z-axis, and this side's y-axis, or you can consider AB, AD, and that vertical also. Now, here what I'll do, summation m, first condition, summation m about y-axis, it is equal to 0. Why I have taken y-axis? Because 2 unknowns are there on y-axis. Then what is the moment of 16 about y-axis? 16 into 200 minus anti-clockwise TC, which is known, 2.2 into 500 minus TB into 500. It is equal to 0. And then from this, we'll get TB. TB is going to be 16 into 200 minus 2.2 into 500 divided by 500. It is 4.2. TB is going to be 4.2. 4.2 kilometer. Means one more answer we got. TC we have to decide. TB is very first answer which we are getting. Now twice m means summation m about x-axis also. X-axis is equal to 0 or about AB equal to 0. Then now if we are standing over here, the moment of TD, TC is clockwise and moment of 16 is anti-clockwise. Moment of TD, TD into 400 plus TC means 2.2 into 400 minus 16 into 150. It is equal to 0, and from this we will get TD. So this also we can make easily the calculations. it is 3.8. TD is 3.8 kilonewton. Means all the answers must be greater than 2.2. Means we are on right path. And now the last step is very simple. Summation F is equal to 0. Now all the forces are along Z. Summation Fz, it is equal to 0. TA, which is unknown, plus TB. TB we have calculated 4.2 plus TC 2.2 plus 3.8 minus weight, it is equal to 0, and we'll get TA is equal to 5.8 kilonewton. So these are the three answers. TA 5.8, TB 4.2, TD 3.8, and TC it is going to be 2.2. So these are the tensions, and see, from this point, nearest point is TA, and maximum tension we are getting in TA. Means whatever the solution is there, it must be correct. Now we'll see the third example on equilibrium of parallel forces. And the problem is like this: a uniform equilateral triangular plate weighing 2.4 kilonewton is held in horizontal plane by means of 3 cables at A, B and C. An additional load of 1.2 acts at the midpoint of edge AC of the plate. Determine the tensions in the cables. So again, excellent example. So here we need the knowledge of geometry also. So first we'll draw the free body diagram of this. So free body diagram means what? We'll be drawing this equilateral triangle. This is the equilateral triangle, and exactly at its center this weight is there, 1.2 kilonewton, and the cables are there at these three corners. Means when we draw the free body diagram, these are going to be in upward direction. So it is TA, then it is TB, and this is TC. Now where the weight will act? Weight will act if I join the corner from this midpoint. So the center of this triangle will be 1/3 from the base, whatever its height is there. Let us consider this height is h, and if this equilateral triangle is there, so whether it's some dimension is given, it is, the dimension is not given. So uniform equilateral, let us consider this side is A. Equilateral means it is A, it is A, it is A by 2. It is A by 2, and if this height is h, this point will be h by 3 from this point, and the weight is going to be like this. Weight is going to be like this. It is 2.4 kilonewton. Correct. Then now, how we'll consider the axis? We can consider this as the origin. This as the origin. We can consider this as z-axis, this as x-axis, and perpendicular to it as y-axis. So these are the two. So because it is going to be perpendicular, that means it is y-axis, it is x-axis, and vertical is z-axis. Then again we have drawn the free body diagram. Once we draw the free body diagram. Then after that, what we have to do? Use summation m about. Now here unknowns are what? TA, TB, TC. Means on y-axis two unknowns are there. So what I'll do? About y-axis, it is equal to 0. It is equal to 0. Then about y-axis, while taking the distances, how we can take the distance? So for taking the moment, either h is required or h by 3. So how the moment will be? Moment of TA and TC is 0. The moment of 2.4 into h by 3, whatever that height is there from this point. So this is the overall height. So it is going to be h by 3 minus TB into h. It is equal to 0. Means what we'll get? One answer will get TB is equal to 0.8 kilonewton. 0.8 kilonewton. So it is the first answer. Now, second is what? Take the moment about x-axis, twice moment, summation m about x-axis, it is equal to 0. Then moment of TB and 2.4 is 0. Then the moment about x-axis of TA is clockwise, TC is anti-clockwise. And distances are going to be a by 2 because it is a midpoint. Means if we are considering TA, if we are looking from this side, TA is clockwise. TA into a by 2 minus TC into again a by 2. It is equal to 0. A by 2 will get cancelled and we'll get TA is equal to TC. This is the second relation. And now third step is what? Summation FZ is equal to 0. TA means TC plus TC, then plus TB is 0.8 minus weight 2.4 minus this also 1.2. 1.2, it is minus. It is equal to 0. Means what we'll get? 2TC is equal to 3.6 minus 0.8. 3.6 minus 0.8 means 2.8 divided by 2. Hence, we'll get TC is equal to 1.4. 1.4 kilonewton. And if we get TC is equal to 1.4 from equation 2, hence TA also 1.4 kilonewton. So these are the answers. Means TB, TC, TA. Or yeah, at the end we can write answers. TA 1.4 kilonewton, TB 0.8 Newton, 8 kilonewton, and again TC, it is 1.4 kilonewton. So these are the answers. Means like this, for equilibrium of parallel forces in space, if you use this simple technique, free body diagram, 2 times summation m is equal to 0 and 1 summation f is equal to 0, will reach to the answer. So like this, easily we can solve the problems of equilibrium of parallel forces in the space. Thank you.